Properties of the unilateral Laplace transform. So unilateral Laplace transform, we have found the signal x of t, it is in time domain, has the Laplace transform x of s. So this is a Laplace transform of unilateral function. Similarly, y of t is a pair in Laplace transform is y of s. So the first property is the linearity. So the linearity of the Laplace transform, we can say from the definition, is an integral, and we can write a into x of t plus b into y of t is equal to unilateral Laplace transform of this is a into x of s plus b into y of s. So this is as per the linearity definition. Second is the scaling. So the function in time domain is x of t, it is scaled by a. So this is a scaling factor. If the scale this scaling factor is there in the time domain, then its corresponding Laplace transform of the unilateral Laplace transform, so it is a s into s by a 1 over a. So this is the scaling in time introduces the inverse scaling in s. So this is scaling in time, it introduces inverse scaling in s. So it is a inverse scaling in s, and for a is greater than 0. This is for a is greater than 0. Next is the time shift. Next property of this is the time shift. We can write here a scaling in time introduces the inverse scaling in s. The inverse scaling in s. Next property is the time shift. So x of t minus tau. So this time function, continuous time function, is given x of t, and now it is a delayed by some time. So x of t minus tau, so its Laplace transform, the unilateral Laplace transform, it is a e raised to power minus st into x of s. So this is for all tau such that x of t minus tau into u of tau is equal to x of t minus tau and u of t minus tau. So this is the time shift property. Next property is the s domain shift. So e raised to power s naught t into x of t, its unilateral Laplace transform is given x of s minus s naught. So this is a s domain shift. So multiplication by the complex exponential. So this is the continuous time signal. If you multiply this continuous time signal by the complex exponential in time, this will introduce a shift in the complex frequency s into the Laplace transform. Next is the convolution property. So we know the x of t, which is convolved with y of t. Its Laplace transform of the unilateral function is equal to x of s into y of s. So the convolution in time, this is convolution in time, correspond to the multiplication of Laplace transform. There will be the multiplication of the Laplace transform if there is a convolution in time, and this property only applies when x of t is equal to 0 and y of t is equal to 0 and for t is less than 0. So we can write here convolution in time domain corresponds to multiplication of Laplace transform. So next property is the differentiation in the ES domain. DIFFERENTIATION differentiation in ES domain. So the differentiation in ES domain corresponds to the multiplication by minus t in the time domain. The differentiation in ES domain corresponds to multiplication by minus t in the time domain. So the differentiation in ES domain, so this is the differentiation in the ES domain, and this will, the differentiation in ES domain corresponds to the multiplication by minus t. So suppose this is x of t and it will be multiplied by minus t. So the differentiation in ES domain corresponds to multiplication by minus t to the x of t. So this is a differentiation in S domain. Next is the find the Laplace transform of find the Laplace transform of x of t is equal to minus e raised to power 5 into u of t convolved with t into u of t. So we have to find the Laplace transform of this. So we have to use this property. Just we have seen the properties, and for that property we have to so we know that minus e raised to power 5t into u of t. So what is the Laplace transform for this? It is s minus 5 and it is minus sign, so it is minus 1 over s minus 5. And what is the Laplace transform of the unity function? It is 1 over s. Now applying the S domain differentiation, we know that t into u of t s domain differentiation. So t into u of t, what is the Laplace transform for this? It is a 1 over s square, and therefore by the convolution property we can directly find the Laplace transform of this function. So by the convolution property we can find x of t is equal to, which is given, minus e raised to power 5t into u of t, which is convolved with t into u of t, and therefore the Laplace transform of this is minus 1 over s square into s minus 5. So this is a Laplace transform. Laplace transform of the given function. So what is the Laplace transform of this t into u of t? It is a 1 over s square. So 1 over s square, and e raised to power minus 5 into u of t, it is a minus 1 over s minus 5. So in this way we can find the Laplace transform for the given signal. Thank you very much for watching the video.